Good morning, Aquarium Online Academy. Thank you so much for joining us on this fine Wednesday morning. My name is Sarah, and I work here in the Education Department at the Aquarium of the Pacific in Long Beach, California. And today we're going to talk about something really cool. Now, I do have some animals floating around behind me, and this is going to kind of give you a hint of what we're going to talk about today. Oops, gotta adjust my mic. We are going to talk all about tidepool habitats. So we're going to focus on what is a tidepool habitat, and then we'll talk about some of the animals that we'll find in a tidepool and how these animals survive in that habitat. Now, before we get started, we're going to put up a text line because we would love to hear from you. If you have any questions about what we're talking about, if you make some observations and you'd like to share them with us, or if you just want to know a little bit more about something that I mentioned, go ahead and text us. That text number is right here. It's 562-286-1838. Now, I'm not alone here in the studio. I have Amanda who's controlling all the things you see behind me, and James is out here on the computer, and he's going to take those text questions or observations or thoughts that you send in, and he's going to give them to me, and we'll talk about them live on the air. Now, if you're watching this program and it's not live, so it's not Wednesday, September 16th at 10 a.m., you can still send us your observations and your questions. We just ask that you email us. That email is right below that phone number. It's live@lbaop.org. We'd still love to hear from you, but send us those emails and we'll get back to you as soon as we can. All right, are you ready to get started? So I mentioned that we are going to talk about habitats. Now, starting off, what is a habitat? Have you heard that word before? It's kind of a big word, but what is a habitat? Now, if you know what a habitat is, you can think it in your brain. You can say it out loud. You can tell someone you're sitting with. You can even text us in what you think a habitat is. So think about a habitat. Now, we can find habitats all over the world, on land and even in the ocean. And right here, this picture is a habitat. So a habitat is where an animal lives. Now, it can be as simple as that, as just where an animal lives. But if we think about it in a little bit more detail, it can include everything around that animal, their community, the structures around them, maybe the weather can play into that habitat, or even the other animals they may interact with are part of their habitat. Now, there's lots of habitats, like I mentioned, on land, thinking about a rainforest or mountains or even a tree. Those are all habitats. But in the ocean, there are a lot of habitats as well. Now, that might seem kind of surprising because if you look out at the ocean, it just looks like a body of water, right? So you just might think, oh, there's just one habitat, it's the ocean. But if we dive below the surface, we will see lots of habitats in the ocean because animals might need different types of places to live. Now, this right here is a kelp forest, and this is one really cool habitat. It's local to us here in Southern California, and this is a home for certain animals. They like to live among these blades of kelp. They can swim through them. They might eat part of it. They might hide like it or hide in it. They might have the same color or body shape as these blades of kelp. And so that is their habitat. But there might be some bigger animals who maybe can't hide. They might get tangled up in that kelp. And so they may need a different habitat like an open ocean. Or there might be some animals who live in the sandy bottom. So there's lots of habitats in the ocean. And we are going to focus on one habitat today. It's one of my favorite habitats. We're going to focus on the tide pool. So this right here is a tide pool. Now I'm going to step off the screen and I want you to take a moment and look at this habitat and make some observations. So we're going to try and understand what a tide pool habitat is. What makes up this habitat? Because it's part of the ocean, but as you'll notice in this picture, is it completely underwater? Not all of it. So what do you notice in this picture? What colors do you see? Maybe textures? What shapes? What things do you notice about this habitat? So let's see. I can make some observations. I see a lot of rocks. Do you guys see the rocks? There's rocks here, and here, and here. And the rocks even look like they have different textures on them, right? This one almost looks kind of spiky, and so does this one, if we look really close. And then these rocks up here, they look kind of flat. Ooh, and there's even looks like there's, I don't know, maybe some green, almost furry stuff there. And then we see there's big open ocean back here, right? And then this white looks like kind of foam from waves. So let's think about a tide pool. Let's break this word down into two parts because it's two words, tide and pool. So think about a pool first. Think about a pool. What do you need to make a pool? You might be thinking of your swimming pool at home, and you might think of a pool of water you find on the ground. But what do you need to make a pool? One thing you need is water. I mentioned it, right? To have a pool of something, you need a liquid. So we're going to think about water is one part, or one thing you need to make a pool. And what's the other thing? Thinking about maybe the shapes we saw in that picture or the shapes of your pool, you need something to hold it. So you need a container. So the two things you need to make a pool are water and a container. something to hold it. And for our tide pool here, it's going to be the rocks that are that container, and the ocean providing that water. Now let's think about that first word, tide. So what is a tide? This word is a little bit more maybe detailed, or can be kind of confusing to think about over that word pool. So what is a tide? So it has to do with the waves and the movement. And we have 2 high tides a day and 2 low tides a day. So the tide is basically the water level, or the level of the ocean as we see along our coast. And like I said, there's 2 high tides a day and 2 low tides a day. And the tides are dependent on the gravitational pull from the moon. So the moon actually controls our tides. And when it's high tide, the water is going to come rushing in, and that water level is going to rise. And then when the tide goes out, the water level is going to go down. Now we're going to watch this video, and this is a great depiction of the tide coming in as we see the waves crashing. Oh, here it's sped up because it does take time. Like I said, there's 2 high tides a day and 2 low tides a day, but that is a span all day. So it goes high tide, low tide, low tide through 24-hour cycle. So it doesn't happen in just a couple minutes like we saw there. Now I'm going to switch over to my document camera, and I'm going to draw a really quick picture. So this is nothing fancy, but this is going to be the rock structure. And I'm going to draw some water up here. And then I'm going to draw me. And I'm very happy to be at the tide pool because I love the tide pools. So I come to the tide pool, and it's a nice sunny day. There we go. Now you can see me. Very happy to be at the tide pool. So here's the water up here. Now if you look at this picture, would you think that this is high tide or low tide? Think about it for a moment. We see the water, and we can see underneath all that rock structure. So would you say this is high tide or low tide? What do you think? Well, if you said high tide, you're right. Because think about it. Look how high this water level is. It's covering all these rocks and everything below, and all this water is filling in this space. So I'm hanging out at the tide pool. Like I said, I love to go to the tide pool. My parents used to take my brothers and I to the tide pools all the time to explore. So I love being at this type of habitat. But then I get a little hungry. So I leave, and I have a snack, and I come back a couple hours later. Do you think the water is still going to be here? No, it's going to move. Now, do you think that water level is going to rise, or do you think it's going to go down? We said that when it looks like this, it's high tide. So what comes after high tide would be, that's right, it would be low tide. So the water level is going to recede. It's going to go back out. So here's the water down here now. And what happened when that water went back out is those holes in the rocks trapped all that water. So it's kind of hard to tell because it's all black. But these spaces here are pools of water. And what happens is there are lots and lots and lots of animals who live in those little spaces in the rocks. And these animals make their home in the tide pool. Now, these animals are really cool. It's very cool to be able to go see these animals in their habitat. It's easy to walk out to a tide pool and explore those animals. However, for these animals that make their home in these little spots, it's one of the toughest habitats in the ocean to live in. Now, I want you to think about, why might it be really tough for animals to live in a tide pool? What are some factors or things that these animals have to deal with? Think about what we drew or what we saw coming in. Think about those waves. So these animals who live in the tide pools, they have to deal with waves crashing on them over and over and over all day long. Now, I want you to think. Think about, oh, here's a good picture, and I think there's a video. We can watch some wave movement. So think about these animals. They're living in this place that are getting hit by those waves over and over all day long, constantly. Do you think that would be an easy place to live? Probably not. Think about if I'm at the tide pool, and I'm sitting on a rock, and I look next to me, and I see a little snail. And the waves start coming in. And we start getting hit by those waves. Who do you think can hold on longer and better to those rocks? Me or that snail? I mean, I have arms, and I have legs, and I can maybe hold on really tight. But I think eventually I'd get pretty wet and probably pretty tired. And I'd eventually let go. But that snail has something special on its body that helps it live in the tide pool. And that's what we're going to start to explore now. We're going to talk about some of the animals who live in the tide pool and the ways that they can hold on to the rocks and the ways that they survive in their habitat. Here's our snail. And that snail is going to use a suction cup. Now, a suction cup is something sticky on this animal's body that's going to help them hold on to the rock. But what this suction cup is, it's an adaptation. Now, I know that's a big word. Let's say that word together. Adaptation. Now, what an adaptation is it's a tool or something on an animal's body, or even a behavior that helps that animal survive in their habitat. So the snail has a suction cup that helps it stick onto a rock, and if a wave comes and hits that snail, is it going to go anywhere? Nope. It's stuck nice and safe, and that suction cup is the snail's adaptation. Now, if we look at this snail, do you think you could find some other adaptations? What else does this snail have on its body that helps it live in its habitat? Think about it. Take a look. So this orange part right here, this is the snail's body, and right here is where their suction cup is. But what is this thing? Right here. What does that look like? Have you seen that before? You might find them on the beach with nothing in them. That's a shell. And the snail lives inside that shell. Now, think about a shell you find on the beach. How does it feel? It might be kind of smooth or bumpy, but is it squishy or is it hard? It's really hard. And so that hard shell acts as another adaptation. It's another thing that helps this animal survive in the habitat, because that snail can stick to a rock and hunker down in its shell, and then if a wave hits that shell, it protects the body of the snail. So snails have more than one adaptation, as most animals do. They have their suction cup, and then they have that shell to help them survive in the habitat. Now we're going to explore some other animals, but first I see that we have some questions coming in, so I'm going to take those questions, and then we'll get back into exploring tide pool animals. So Silas in 2nd grade wants to know what kind of animals live in the tide pool. Excellent, Silas. You read my mind of what we're going to get into next. Now, this is a really cool picture. This is a picture of a tide pool. So if you go to a tide pool, we have them all along our coast here in Southern California. We have them in Cabrillo. We have them in Newport Beach. They're in Malibu, all over. But even if you're not in California, there's lots of places where you can find tide pools. And they look similar to this. Now, depending on where you go, you might see different animals. And depending on what the tide is like, you want to go to a tide pool at low tide. But there's definitely levels of tide. So some animals live in the upper tidal zone and are easier to see, and some live in the lower tidal zone. But this is a kind of a good picture of what you might see, what kinds of animals you might see when you go to the tide pool. So let's think, what can we see here? Do we know what this animal is? This is probably the easiest to guess, the most obvious one, a sea star or a starfish. So there's lots of sea stars. These are called ochre stars, and they come in all different colors. You can see a purple and kind of a purplish pink, and then we even have, whoop, there we go, an orange one. And then what do you think these things are? Have you seen those before? Those are anemones. So we're going to talk a little bit more about these animals. But first, I see we have another question. Lily wants to know, do sea stars do somersaults? Excellent segue, Lily. Let's start talking about sea stars. So, sea stars, they live in the tide pool. Now, we have lots of different types of sea stars we might find in the tide pool. Like in that picture before, those ones were called ochre stars. These ones right here are called bat stars. Now, bat stars are a little bit smaller, a little bit thicker. We can kind of see they have this webbing between their arms, and that gives them that name of bat star. Now, it kind of looks like they might do somersaults. They might kind of turn their whole body like a sea star cartwheel almost. But for the most part, they're going to want to hold on to those rocks. Because think about, if a sea star is off having fun doing somersaults and cartwheels and a big wave comes, what could happen to that sea star? It might get knocked over. It might get swept out into the open ocean, which is not where its habitat is, and it might make it really hard for that sea star to find food and to survive. So for the most part, sea stars are going to hold on really tight to the rocks. But how are they going to hold on? What adaptation do sea stars have? Well, I think Amanda's looking for a picture. She's going to show us the underside. So right now we're looking at the top of the sea star. If you were to look down at the sea star, this is what you see, their colors. Ooh, but this is the underside. So if you go to a tide pool, you may not see this part of a sea star because this is the part that is holding on to the rocks. But this sea star here at our aquarium is holding on to a glass window, and so we get a really good view of the underside. Now, these things right here along their arms. So they have arms. How many arms does a sea star have? Should we count? Ready? 1. Oop, here we go. I can do this. 2, 3, 4, 5. 5 arms in the star. But if you look along the middle, the midline of these arms, you see these little circles or little tubes. And those are the feet of the sea star. Now we call these feet tube feet. Not 2 feet, but tube. T-U-B-E. Tube feet. I think they look like macaroni noodles. But these 2 feet actually have suction cups at the end. So all of these tube feet, every individual tube feet has one suction cup at the bottom that helps it stick onto rocks, or glass in this case. And those tube feet help a sea star hold on really tight to the rocks so that they don't get swept away with waves. So that's one adaptation of our sea star. Now, sea star, no, it's okay. So this picture is of our coastal corner here at the aquarium. And you can see a lot of sea stars in here. A lot of them look kind of lazy, like they're just kind of lounging around. We've got our painted greenling fish swimming around. These sea stars, they are all using those suction cups to hold onto the rocks. So even as there's movement in the water, they're going to lie flat and hold onto the rocks. Now, those suction cup feet are not only used to hold onto the rocks. They're used for a lot of different things for that sea star. Now, that sea star, think about where do you think their mouth might be? As we look at the top, does it look like it has a mouth on top? No, not on top. Their mouth is actually on the bottom. And those feet, they help the sea star do something that it needs to do with its mouth. So the sea star, they need to find food, right? All our living things need to find food to survive. Our sea star is actually going to use its feet to find its food. Now, how do you think it's going to find its food using its feet? It can actually smell with its feet. Can you smell with your feet? You might have stinky feet, right? After we run around all day, our feet might be kind of stinky, but we don't smell with our feet, we smell with our nose. But our sea star, those suction cup feet, not only are used to hold on to rocks, but they can actually smell for their food. They have smell sensors in their feet. Here's a cool video of a sea star walking around. So this sea star is walking along the sand and it's sniffing or smelling for food. So those two feet are used to hold onto rocks. They're used to smell food. They're also used to help the sea star eat. So sea stars, they like to eat things like mussels. Mussels are one of sea stars' favorite food. But a mussel is an animal that has these really hard shells, two shells that open and close like this, and they hold on really tight. Now, that sea star wants to get to the inside of the mussel. They don't want to eat the shell. And so they're going to use their two feet to grab a hold of the mussel shell and pull them open. And they have to use a lot of strength, a lot of muscle. So they pull till they get that mussel open. And then, if you thought sea star was strange, it's just going to get stranger because sea stars eat their food in a really weird way. So sea stars, let's talk about. First, they use their feet to hold on. They use their feet to smell. They use their feet to open up the shell of their food. They don't use their feet to eat. What they actually do is they take their stomach, they pull it out of their mouth, and they stuff it into the shell of the mussel clam. They make a soup out of that mussel clam, and then they slurp it back into their body. So here's a cool view. So you wouldn't see this if you go to the tide pool, but we have one of our sea stars. This is actually a chocolate chip sea star. If only it tasted good like a chocolate chip cookie. But this chocolate chip sea star is eating, and you can see this right here. All this yellow stuff is their stomach mixed in with their food. So their stomach kind of looks like a bunch of little balloons sticking out, and they pull it out of their stomach, and it has acids in it that help digest the food, just like our stomach helps break down our food. So they can break down the mussel, they get all the little pieces of it broken down, and then they slurp it back into their mouth. Can you imagine if we did that? Think about if you got to school and you had your lunchbox, and at lunchtime you open your lunchbox, you pulled out your stomach, you put it in your lunchbox, close your lunchbox, shake it up really good, and then open it and slurp it back up. Can you imagine how weird we would look taking our stomach out of our body? Now, we can't do that, but that is how the sea star eats, is they remove their stomach from their body, they eat their food, and then they swallow it whole. Now, this animal is pretty incredible, these sea stars. So they not only hold on to the rocks with their feet and smell with their feet and open their food with their feet and take out their stomach to eat, but there's one more incredible thing I want to mention about the sea star. Now, you may have heard this. Our sea stars are pretty incredible animals. And we talked about they have how many arms? 5 arms, right? Now, what happens if maybe a rock falls on a sea star or an animal might eat one of the arms of a sea star? What do you think might happen? Do they have 4 arms for the rest of their life? That might make things difficult, right? If a sea star has its 5 arms that it wraps around that mussel clam to pull it open, but it's missing an arm, that might make it really hard for that animal to eat. So, another adaptation of this animal. Ooh, this is a cool picture. This picture was taken by the photographer, Joel Sartore, and he takes pictures of a lot of animals, and this is a leather star that he photographed for us. Now, if this leather star were to lose an arm, like I mentioned, it'd be hard for it to feed the same way. So what they can actually do is they can regrow a brand new arm. Now, it's a big word. It's called regeneration. Let's say that all together. Regeneration. What that means is it can regrow a new arm. So if something happens to its arm, a sea star is going to grow a new one, so they will always have 5 arms. Pretty incredible, right? For such a small little animal, these are pretty incredible creatures. All right, we're going to move on to another animal, but I did see we have some more questions. So we're going to pause on animal exploration and take these questions. So Noah wants to know, how long do sea stars live? Ooh, That is a great question. It really depends, one, on the type of sea star and the habitat where that sea star can be found. We're talking about sea stars in the tide pool, and some live in the lower tidal zone. So even at a low tide day, you may not be able to see certain types, and some live in the upper tidal zones. But we think sea stars can live upwards of 100 years. There's not a lot of predators for sea stars. When we're looking at their body, ooh, this is a sunflower star. Look at all those 2 feet. So many feet. These animals, they don't have a lot of meat on them, so there's not a lot for an animal to eat. So they don't have very many predators, and they are one of the top predators in their habitat. Sunflower stars, ochre stars, another type of sea star, knobby stars, they eat mussels, they eat clams, they'll eat anything they can find, but not many things eat them. So they can actually live a really long time. Great question. All right, Evelyn wants to know, how did or do the tide pools form? That's a good question. So all these rock formations that we have along the coast, a lot of rocks can be formed from earthquakes or volcanic activity. And when these rocks form right along the coast, the waves are going to keep crashing. So you might find a sandy beach with the waves crashing. But if there's rocks right along the beach, the waves are going to crash along those rocks and animals are going to find a place to live. Good question. And Kancha wants to know, what do stars eat? Oh, excellent, Kancha. So we just mentioned that sea stars, they eat mussels, they eat clams. Here at the aquarium, we'll even feed them fish or pieces of squid. They can kind of eat whatever they can find. Thinking about a tide pool, do you think there's tons of options for them to eat? Probably not. So a lot of animals are going to eat what they can find. They're going to scavenge and eat pieces of food that maybe another animal ate, or whatever they can find, that is what they're going to feed on. All right, so we talked about one animal that we find in this tide pool. Now I'm going to let Amanda choose. She's going to bring up another animal that we find in the tide pool, one of her choice, and we'll see if we can identify what type of adaptations this animal has living in its habitat, or in this tide pool habitat. Let's see, what animal? There are so many to choose from. Ooh, excellent. So there's actually a couple different animals that we see here in this photo. This one right here with the white kind of spots on it, or little pieces, these are called Gooseneck Barnacles. But I want to focus on this animal right here. Right here, right here, right here, right here. Does that animal look familiar? You might recognize the shell. I have a shell I can bring over and hold up to show you. So this right here is the shell of this animal. Here we go. This is a mussel clam. So a mussel clam is a type of clam. It's got 2 shells that open and close, and like I mentioned, that is one of the sea star's favorite food. Now, this mussel clam has its own adaptations to survive in the habitat. Take a look at this picture. What do you notice? Do you see just one mussel clam? Do you see just 2? No, there's a lot of mussel clams mixed in with those barnacles. So we call that safety in numbers. So these animals are on the smaller side, and they tend to live with a bunch of other animals of that same species. So we find tons and tons and tons of mussels and barnacles and gooseneck barnacles all packed together in one area. And that can help them stay safe because, I'm going to put this shell down. That helps them stay safe because it, one, makes them look like a bigger animal, or it's harder for a predator to get to one individual if they're all packed together. Now, what's kind of hard to see in that picture is the way that the mussels hold onto the rocks. Ooh, here's a good picture too. So you can see all these, there's 2 types of barnacles. We have barnacles here, gooseneck barnacles, and then that mussel clam. Now, we talked about for the sea star, they use suction cups to hold on, but the mussels, they don't have suction cups. They actually use rope. Yeah, you heard that right. They use rope. Kind of like they tie themselves with a rope onto the rock. They're called Bissell Threads. They're these strings that come out of the shell of the mussel, and they stick onto a rock, and they can hold on super tight. If you try to pull them off, they are not easy to take off the rock. Those threads, or those ropes, tie on really, really tight to the rock, and they anchor that mussel into the rock. And so if a wave comes, they might wiggle a little, but that mussel is not going anywhere. So the adaptation that a mussel uses, besides its hard shell, of course, are those threads or strings or ropes that it uses to tie onto the rock. All right, we have another question that came in. Genesis wants to know, do stars lay eggs? How do they have babies? Ooh, that's a great question. So sea stars are going to lay eggs, but the way that sea stars lay eggs or give birth is something called broadcast spawning. And what that means is these animals, the males and the females, are just going to send the eggs and the sperm up into the air, or into the water, I should say. So everything goes up into the water column, and they hope that they meet. Look at these sea stars right here. There's a bunch of sea stars all packed together. And these sea stars, that's how you'll find them in the ocean. So when they send everything up into the water, they hope they meet, and the likelihood of them meeting is pretty high because these animals live pretty close together. So then once they meet, there are eggs that are going to settle and hatch, and then we have sea stars. Now here is a good picture of what it might look like at the tide pool with all these animals packed in together. Because think about that drawing that I showed earlier. These animals are living under the water, and then when the water recedes, they're stuck in whatever little crevice of rock they were in. They don't want to be out of the water for too long. Here we go. So think about if these animals, when the water is really high, they have all this space, but when the water goes back, they're stuck in these little pools because it could be dangerous if they go out of the water. They could dry out. There could be other predators. So they're going to stay in these little pools. So if we go back to that picture that Amanda had up, we'll see that all these animals are packed together. They live in close quarters. So the likelihood of these animals meeting together is pretty high. Now let's take a look at this picture. There's a lot of animals to explore here. So we've talked about our sea stars. This one right here is the ochre star. This one down here is that bat star. But do you see any other animals in here? We've got quite a few animals. We only have a couple minutes left, so let's talk about this animal right here. Does anyone know what that one is? It's got kind of a hard name to say. That's a sea anemone. Let's say it all together. Sea anemone. And we find lots of sea anemones at the tide pool. Now, sometimes these sea anemones, we've got the big sea anemones here, will be in the water, and sometimes you might even find them stuck on those rocks outside the water, but they have a special adaptation where they can pull all those tentacles into their body and close up and hold water inside their body, waiting for that tide to change. So here we go. These animals are not in the water. They are exposed, but they can pull all those tentacles in. So these almost don't look like that same animal. They do have those wavy tentacles, which we'll talk about what those are used for in just a moment. But they do have those tentacles, but they've pulled them in. They're holding them inside, and they actually hold water inside so that they can stay wet and moist and they can breathe while they're out of water. And then you'll notice all these things that look like little white spots, those are actually tiny anemones. What they've done is they've kind of created a disguise for them. They've taken all these little bits of shells and rocks and stuck them to the outside of their body. And that way they look like a rock instead of like an animal, and they can hide from predators. So these things, all you see up here, right here, right here, right here, so many of them. Too many to point out all of them. Those are all teeny tiny anemones. Now, here's a great picture of anemone, and we said we're going to talk about what those tentacles are. So anemones, they are in a family called cnidarians, and they are in that family with jellyfish. Now think about jellies, sea jellies. What's an adaptation of a sea jelly? What do they do to protect themselves? If you said they sting, you're right. So that's the characteristic of these animals in this group, cnidarian, is they have stinging cells. So these tentacles all have a stinging cell in them. Now, these stinging cells can be used to protect the animal. If a fish or an unwanted visitor comes to the anemone and the anemone doesn't want anything to do with that animal, they might sting them, but it's also how they're going to catch their food. So we talked about before, the sea star uses its feet to smell for its food. The anemone doesn't move very much. It's pretty much stuck to a rock. Some anemones will suction cup themselves, some will glue themselves to a rock, and then they've got these long tentacles they're just going to wave. Plant-like animals. Here we go. It's a perfect picture or video of them waving. They kind of look like plants. So an animal might swim through thinking it's a plant, and the anemone is going to use its tentacles with those stinging cells to catch its food, and then it's going to pull it into its mouth, which is in the middle of its body, right there. Just like the mouth of the sea star was in the middle. But the anemone is going to catch its food with those tentacles, pull the food into its mouth, and then it's going to digest it. Now I want you to take a look at this video. What's another difference you notice between the sea star and the anemone in the shape or the structure of their body? So we mentioned that the sea star has 5 arms, and they're pretty flat. And what I didn't mention is the sea star's body is pretty hard. People are sometimes surprised when they touch a sea star to realize just how hard their body is. It's made of these calcium structures, and it's kind of like a plate of armor that protects that animal. So they're pretty flat to the rock. They have a hard body. But look at these anemones. Do they look like their body is pretty hard? No, this anemone is kind of just like moving back and forth. You can sway with me like an anemone. It's kind of moving with the water. So anemones have this long stalk of their body, but it's really flexible. And that can help them in the waves, right? So if this anemone can just move wherever the water goes, if they get hit by a wave, it's not going to hurt them the same way if they were standing really straight and really rigid. So they just kind of go with the flow, we like to say, with our anemone. So this kind of soft body and these tentacles just kind of move with the water, waiting for an animal to swim through for them to eat. So the adaptation of our anemone are those stinging cells and also the structure of its body to help it survive in that wave-ridden habitat of the tide pools. Well, you know what? We are just about out of time. I could keep talking. There's so many cool animals to discover in the tide pool, but we are out of time. If you have any last questions or thoughts, go ahead and text us or use that email to send us those questions, and we'll get back to you when we can. We're going to leave you with this beautiful sunset view of the tide pool. If you do have a chance to go explore a tide pool, I highly recommend it. It's very cool, and I hope you have a good rest of your day.